Welcome to Module 13, Introduction to Power BI Topic 2. By the end of this module, you will be able to, first, publish Power BI reports to share analytical insights. Second, create interactive dashboards for visualization and app building. Third, use natural language queries to analyze data. And fourth, apply key DAX functions including time intelligence functions. Keep these objectives in mind as we progress through the slides and demonstrations. Before you can use Power BI service, you need an account. To get started, go to app.powerbi.com and sign up using your USI email address. Once signed in, you will have access to your workspace where all your reports and dashboards will reside. The screenshot here shows the sign-in page, highlighting the email field and sign-up options. In the Power BI service, you can generate quick insights on your datasets. From your workspace, select the ellipsis next to the dataset you want to analyze and click Get Quick Insights. This action triggers Power BI to automatically search for patterns in your data. The image on the slide highlights the dataset list and the ellipsis menu option. After about 15 seconds, Power BI notifies you that insights have been found. Click the View Insights button to see a page of automatically generated visualizations. The screenshot shows the notification and the button to view insights. Once you're viewing the insight cards, hover over a card and select the pin icon to add the visualization to a dashboard. You can choose which dashboard to pin it to. The slide image shows the pin icon on a sample insight card. Navigate to the dashboard where you pinned the visualization. This allows you to consolidate multiple insights in one interactive view. The screenshot highlights a dashboard with a newly pinned tile. Hover over the pinned card, select More Options the ellipsis, and choose View Insights. This opens the insight in focus mode. In focus mode, you can apply filters and explore the data in greater detail. The image shows the ellipsis menu and the focus mode button. Dashboards in Power BI are single-page collections of visualizations that can be created directly in the service. You can create a dashboard by pinning visuals from reports. The slide image demonstrates a sample dashboard with multiple pinned visuals from different reports. Dashboards allow you to monitor your business and view key metrics at a glance. They can include visuals from multiple reports and data sources, including on-premises and cloud data. Dashboards are highly interactive and tiles update automatically as the underlying data changes. The image on this slide shows an example dashboard with dynamic tiles and multiple data sources. You can change the layout of visuals on a dashboard as needed. To resize a tile, drag its handles in or out. To move a tile, select and drag it to a different location. Hover over a tile and click the pencil icon to open the Tile Details pane, where you can edit the title or subtitle fields. The screenshot highlights a dashboard tile and the pencil icon. Power BI includes a Q&A feature allowing you to explore your data using natural language queries. You can type a question in plain English and Power BI will generate the best visualization to answer it. The slide image shows the Q&A question box at the top of a dashboard. Type a question about your data in the Q&A box. For example, what are the total units by region? Power BI interprets the question and selects an appropriate visual. The screenshot highlights a typed question and the suggested visual type. Q&A is available on dashboards and reports. Place your cursor in the question box to open the Q&A screen. Power BI will suggest visualizations automatically, but you can specify a preferred chart type if desired. The image shows the Q&A interface and suggestion options. Q&A picks the best visual based on the data context. For example, numerical values may be shown as a line chart, while locations might be displayed on a map. You can also instruct Q&A to use a specific visual type by adding it to your query. The screenshot displays an example of Q&A generating a map visual. To share a dashboard, open it in Power BI service and click the Share link in the top left corner. Enter names, email addresses, or distribution lists to grant access. The screenshot shows the shared dashboard page with the input fields highlighted. Hover over a dashboard tile and click the ellipsis to see additional options. Select Open in Focus mode to expand the visual to full screen. The image highlights the ellipsis menu and the focus mode button. Focus mode allows you to see more detail in your visuals and legends. Some columns or data points may not be visible in the standard tile view due to space constraints. The screenshot demonstrates the expanded focus mode with full data visibility. After building your dashboard, you can format tiles in Power BI Service. Hover over a tile, click the ellipsis, and select Edit Details to open the Tile Details pane. You can modify the title, subtitle, refresh time, or add a custom link. The image shows the Tile Details pane and the editable fields. You can add tiles containing images, videos, text boxes, or web content. Select the Edit drop-down and click Add a Tile to open the Add a Tile dialog box. The slide image highlights the Add a Tile button and the resulting dialog box for selecting content type. If your dashboard has more content than fits on the canvas, you can manage the view to see all tiles. Click the Full Screen Mode button in the top right corner to remove all interface elements and expand the dashboard. The screenshot highlights the Full Screen Mode button. Within Full Screen Mode, select Fit to Screen to shrink all tiles to a single view. This view, often called TV mode, is useful for presentations where scroll bars are not desired. The slide image shows the dashboard in Fit to Screen mode. Power BI provides several sharing options. You can publish reports from Power BI Desktop to the service, create apps that package dashboards, reports, and datasets, or create groups for secure access. The image demonstrates different collaboration options, including publishing and workspace access. After completing a report in Power BI Desktop, click the Publish button on the Home tab to send it to Power BI Service. The screenshot shows the Publish button in Power BI Desktop. In Power BI Service, select File in the top left corner, then choose Print this page to open the print dialog. This allows you to print your dashboard or report. The slide image highlights the File menu and Print option. You can export data from any visual by selecting the ellipsis on the visual and choosing Export to .csv. This enables further analysis outside Power BI. The screenshot shows the ellipsis menu and the export option. Reports in Power BI Service can also be printed directly. Open the report, select File and Print, and a print dialog box will appear. The image illustrates the File menu with Print highlighted. To update reports or datasets already published, click Publish again on the Home tab. This will overwrite the previous version in Power BI Service with updated data. The screenshot shows the Publish button being used for republishing. Workspaces are collaborative areas for dashboards, reports, and datasets. There are classic workspaces linked to Microsoft 365 groups and new workspaces with granular permission settings. The slide image highlights the workspace creation interface. Click Workspaces and then create a workspace. You can control whether everyone or only specific users can create workspaces. The screenshot illustrates the workspace creation dialog with access options and settings. This slide explains the difference between dashboards and apps. A dashboard is a single-page visualization that provides a high-level overview of key metrics, often combining visuals from multiple reports. An app is a container that bundles dashboards, reports, and datasets, which can be shared with your organization. The screenshot highlights a sample dashboard and an app tile. To create an app, include your dashboard, the underlying reports, and the dataset. After setting up, you can share the app with people in your organization so they can reuse these artifacts. The slide shows the initial app creation screen. During setup, enter the name and description to help users find the app. Set a theme color to personalize it, and optionally add a link to a support site. Choose whether to distribute the app to the entire organization or selected groups. The screenshot shows the app configuration panel. On the Content tab, select the dashboards and reports from your workspace that you want to include in the app. You can adjust which content is shown and the order. The image highlights the content selection interface. Power BI also allows you to publish reports to the web for public access. Click File, then Publish to Web to generate a public link or embed code. The slide image shows the Publish to Web dialog box. Once published, you can share the link with anyone or embed the report in a website or blog. Keep in mind that this is public access, so do not include sensitive data. The screenshot shows an example of the published web report embedded in a web page. Next, we introduce the 3 types of calculations you can add to your semantic model using DAX: calculated tables, calculated columns, and calculated measures. Calculated tables store entire tables derived from existing data. Calculated columns create new columns within an existing table, and calculated measures compute values dynamically for use in visuals. The screenshot highlights examples of each calculation type in a model. Each model calculation type, calculated table, calculated column, or measure is defined by its name, followed by the equals symbol equals, and then the dx formula. Use the following template to create a model calculation. For example, the ship date calculated table duplicates the date table data. The image shows the formula entered in the formula bar and the resulting table in the fields pane. A dx formula consists of expressions that return a result. The result is either a table object or a scalar value. Calculated table formulas must return a table object. Calculated column and measure formulas must return a scalar value. The screenshot illustrates a calculated table and a measure in the model. Formulas are assembled using several elements: DAX functions, DAX operators, references to model objects, constant values like the number 24, or text like phi, DAX variables, and whitespace. The image shows each component highlighted in an example formula. DX is a functional language similar to Excel. Functions allow formulas to perform calculations or transformations. Each function has arguments that accept variables. Functions can be nested within other functions. In a formula, function names are followed by parentheses enclosing the arguments. The screenshot shows a nested SUMX function example. Operators in DX perform arithmetic, comparison, string manipulation, or logical tests. Examples include plus, asterisk for arithmetic, equals for comparison, and for concatenation. The slide image highlights operators in a sample formula. Formulas cannot refer directly to a hierarchy or hierarchy level. Instead, formulas refer to three types of model objects: tables, columns, and measures. The screenshot shows a measure formula referencing a table column. When referencing a table in a formula, enclose the table name in single quotation marks if it contains spaces or special characters. The slide shows a calculated table referencing the date table with the table name in single quotes. Column names must be enclosed in square brackets. You may optionally prefix the column name with the table name. For example, a measure definition referring to the sales amount column. The screenshot demonstrates a column reference in a DX formula. Measures are referenced similarly using square brackets. For example, a formula referencing revenue and cost measures. The slide shows a measure using other measures in its formula and highlights the syntax in the formula bar. Many Excel summarization functions are available in DAX, including sum, count, average, min, max, and others. The main difference is that in DAX, you pass a column reference, whereas in Excel, you pass a range of cells. Other Excel functions for mathematics, text, date, time, information, and logical operations are also available in DAX. Two useful DUX functions that are not found in Excel are distinct count and divide. Distinct count counts the number of unique values in a column, and divide performs division while safely handling division by zero. The slide image highlights these functions in a formula example. Distinct count counts the number of distinct values in a column. For example, to count the number of unique sales orders in the column reseller sales _USD sales ord under, you would write a DAX formula using distinct count. The screenshot demonstrates the calculated measure and the resulting count. The divide function performs division and returns an alternate result or blank if division by zero occurs. The slide image shows an example where divide is used to calculate profit margins safely, avoiding errors from dividing by zero. To use time intelligence functions in DAX, your model must include at least one date table. A date table must have a column of type, date or date, time, contain unique values, have no blanks, include all dates without gaps, and span full years. The date table must be indicated as a date table in the model. The screenshot shows a properly configured date table in Power BI Desktop. This page shows one group of time intelligence functions summarizes data over time. You will create your first time intelligence calculation using total leaded. You must reference the date column of a marked date table. Optionally, you can provide a filter or a year-end date if the year does not end on December 31st. The image highlights the formula in the formula bar and the resulting visual in a matrix. Using the AdventureWorks DW 2020 MO7 file, add a measure to the sales table that calculates YTD revenue. Format the measure as currency with 2 decimal places. The year-end date of 6/30 represents June 30. Add the revenue YTD measure to a matrix visual on page 1 of the report. The screenshot shows the resulting summarization in the matrix. Here we have another group of DAX time intelligence functions handles shifting time periods. Add a measure to the sales table to calculate revenue for the prior year using SAMA period last year format as currency with 2 decimal places. Add the revenue PY measure to a matrix visual. The screenshot shows the matrix displaying prior year revenue amounts compared to the current period. Modify the measure by renaming it to revenue YoY% and updating the return clause to calculate the change ratio. Format the measure as a percentage with 2 decimal places. Notice that the revenue YoY% measure produces a ratio of change over the previous year's monthly revenue. For example, July 2018 shows a 106.53% increase over the previous year, and November 2018 shows a 24.22% decrease. The image highlights these values in the matrix visual. Step 1. Use the sales_analysis file and create a matrix visual using the fields religion and sales. Step 2 is to create a measure sales all region using the provided formula. Step 3 is to create a measure sales % all region using THE provided formula. Step 4 is to create a measure sales % country using the provided formula. Step 5 is to modify the measure using if and isenscope. Step 6 is to create a measure sales % group with the provided formula. Step 6 is to modify the measure sales % group measure. Step 7 is to create a sales YTD measure. Step 8 is to create the year-over-year growth measure. The Step 9 is to create a year-over-year growth % measure.